Hello, and welcome to section 1.7, which is called Formulas of Compounds. And we're going to get to that at the end of this, but first, I just have a little bit of information for you that some of you have already researched and looked into, but for those of you who didn't, this is a little pie chart showing elements in the human body that we see by percent mass. And probably it isn't surprising to you that oxygen is 65% by mass of all of the elements in the human body. Carbon is next, and then hydrogen, nitrogen, and others after that. But definitely between oxygen, carbon, and hydrogen, those form by far the greatest elements in the human body. Elements in the Earth's crusts, oceans, and atmosphere are also interesting. Again, we see oxygen. So oxygen is a very prevalent element in life and on the Earth in general, things that are not alive. We see a lot of silicon also in the Earth's crust, aluminum, iron, other minerals, and other elements after that. But oxygen is by far the most, and then silicon plays a large role in what we see in the Earth's crust. Here are just a few interesting facts. There are 115 known elements. That is a number that changes because scientists continue to discover new elements and continue to be able to come up with new ones in the lab. 88 of those occur naturally. You might see a little variation on that number as well, but roughly 88 that we see in nature. And symbols of the elements are something that you definitely need to be aware of and that you need to know. Here are some of the elements that are named and their symbol is after their name and after the first letter or first two letters of their name. So, for example, fluorine. For that element, we just have a capital F. For oxygen, it's just a capital O. For carbon, capital C. Neon gets a capital N and a lowercase e. Silicon gets a capital S and a lowercase I. When the symbols for the elements are written down, we capitalize the first letter. And if there happen to be two letters, or three sometimes, the subsequent letters after the first one will be lowercase. Here are some symbols of elements that are not the first letter or first two letters in the name. So here, for example, we have zinc. Instead of capital Z, lowercase I, the symbol for zinc is capital Z, lowercase n, even though n is the third letter in the name zinc. Chlorine also is capital C, lowercase l, not the first two letters of the name. Cadmium, capital C, lowercase d, and platinum, capital P, lowercase t. Here are just some pictures that represent some of these elements as well that I thought might be interesting. I'm not sure if you are aware or not, cadmium is a major component in a lot of pigments, paints, and the reds and the yellows. If you've done a lot of painting, will often be named cadmium red or cadmium yellow. Platinum is very popular in a lot of jewelry, and I just thought these tubes of zinc looked really interesting, so I put that picture there too. Here are some symbols of elements that in our language seem to have nothing to do with the name. And that's because we derive the symbol from the Latin or the Greek name for that element. And those include gold, which is symbolized AU. Lead is symbolized PB. Sodium is symbolized Na. And iron is symbolized Fe. And then these are the Greek or Latin words that they were derived from. Here is a chart of common elements, and these are elements that you really need to know. So you can study these, make flashcards, or do something to help yourself really become familiar with these symbols and the elements as well that they go with. Now we can get on to the next topic, which is molecular formulas and how we write those and what they mean. Here we have a molecule, CO2. It's important to note that when we write a formula for a molecule like this, you need to know that each atom is represented by its symbol. So the carbon is represented by the symbol C. The oxygen is represented by the symbol O, which is why you need to be familiar with those common symbols. 2, the number of each type of atom is indicated by a subscript to the right of the symbol. So here, for example, the subscript to the right of the carbon is 6. So we know there are 6 atoms of carbon in this molecule. We know there are 12 atoms of hydrogen in this molecule. And we know there are 6 atoms of oxygen in this molecule. Then the third point, when only one atom of a given type is present, we don't write a subscript 1. So here, there's only one oxygen, but we do not write a 1 in subscript after the oxygen. We just know that's a 1. So if you would just pause the video here in a minute, try this little exercise, see if you can write the formula for a compound containing 1 aluminum atom, and 3 chlorine atoms. And then turn the video back on and start playing, and I will show you the answer on the next page, and you can see if you get it right. All right, is this what you wrote down? 1 aluminum. So we don't write the 1, remember, because we don't write the 1. It's assumed there is 1 aluminum and 3 chlorine atoms. So I'm sure you got that right. And you can try more of those. There's some problems in the book you can check out and practice some of those before you show your proficiency. If you're looking for an advanced proficiency and you want to really go above and beyond, oh, please use your imagination and think of some great ideas, because I'm sure they're better than mine. So I also wrote a few ideas right down here. You're welcome to use any of those as well. So have a great rest of your day, and we'll see you in class.